Hello everyone, welcome to Proof of Concept channel. As part of POC today, I'm going to explain steps 7 to 11 in a detailed way. Earlier videos we've seen that the steps, however, I'm planning to explain it a bit more clear on these steps here. So the step 7 is save the model as a pickle file, load the model to get a prediction using test data, Flask based API setup, simulate the input data using Postman, get the prediction output from the model. Let's go one by one. I am not going to build any model as part of this POC. This is the existing model that we built as part of earlier POC. We are going to utilize this model to how to save this model and how to get the prediction using the Postman API. That's the objective of this POC right now. Let me go to this dataset. We have all these Boston housing price datasets with all attribute details. So you can get familiarized with this attribute information. Here, especially if you see the NOx, nitric oxide concentration, as well as the room, average number of rooms per dwelling. As we know, the nitric oxide concentration more on the air, that will be negatively impact our housing price. Similarly, the number of rooms will be increased, then that will be positively impact our price. Those two use cases we are going to see as part of the POC today. Similarly, we are going to expose our model as an API so that whenever we provide these input values, how our model prediction getting changed, especially the NOx as well as the room count. Based on our earlier study, we know that the NOx will be the negative impact and the rooms will be the positive impact. Similarly, our target variable is median value owner occupied homes, MEDV. That's the target variable. Let me quickly go to the step there we have the model ready. Here. So we are in step 5. Here we are building the model. So our model is available regression underscore model variable. So if you see, this is our model. So we built the model and the model is available for us. So the next step will be we are going to save this model as a pickle file. If you see here the step 7, save the model as a pickle file. I am going to use Google Drive. That's the reason you see the mount Google Drive. I'm just mounting the Google Drive and saving my model inside the Google Drive. So now if you see this my linear model, that's the name of my model. It's available in Google Drive with this path: content, drive, my drive, Colab. Let me go there and quickly show. Yeah, this is where my model is available right now. We can just right click and then download this model so that this will be used while exposing an API. That's an upcoming steps that we are going to see shortly. Now our model is ready. The next step will be I'm going to set up the Flask based API. I'm going to use the PyCharm. So PyCharm is nothing but a Python editor. For this experiment I am using PyCharm, but you can use any editors, Visual Studio Code or IntelliJ. This is my PyCharm editor. Here I just put my model inside the project, but this is one sample project. You can just create one project here, and I placed my model here, my linear underscore model.pickle. That's my pickle file. And if you see this code, we have the import. So the importing, we are using the Flask. Flask is a web application framework. So we are using the Flask library and then pickle library to load the model. And the main, if you see here, I'm just loading p.load of our model. So this is the name of our model, and I'm just loading this model and hosting this into this server. So it's a local host and then port 8200. Similarly, we have one small method, get model prediction. This will accept post and get. So get prediction is the method name. Here we have get the input request. So this is the place I'm getting the input request. So when we fire the request through the Postman, I'll be getting it from here. And the step 3 here, convert the input request into a JSON array to feed the model. So here it's very important because we need to provide the column list. These are all the independent variable as part of the model building. We seen that these are all the attribute information. So I'm just converting these values into an array to provide the input to the model and get the prediction from the model. So the step 3, I'm getting the prediction. I'm using the model dot predict and I'm giving the payload. The payload is the payload as part of the request that we are receiving, that I'm converting into an array and then giving as an input to the model. So in step 4, I'm getting the prediction. So this is the prediction values, and I'm just returning this value, the predicted price value. So this is one sample code, small sample code. This will be available for you. I'll put it in the description below, all this code. Let me quickly start this application, and then I'll set up a Postman and then showcase how this will be working. Let me quickly run this. So now if you see, the server started with the localhost 8200, and it's currently up and running right now. Let me quickly go to Postman and show how this is working. Postman is nothing but a tool that's for validating APIs. This is my Postman, and here I have the post method, and then I put the localhost 8200 and then get prediction. This is the method name. So in the body, you need to provide all the independent variables, the attribute information that we have here. Especially if you see the room and the knocks, this will be the knocks will be negatively impact our price, and the room will be positively impact our price. So I kept all the requests. The request JSON look like this. Let me quickly fire and see what is the response that we are getting as part of this. Okay. So now if you see, I'm getting the success response, and the predicted price from the model I'm getting is 23.87. So this is the output from the model, and the status is 200. So which means it's a success. So our model, when we provide these attribute information as part of the request, and we are getting this output from the model. This is how, as a production-based application, we will be deploying our model into the server and exposing as an API, so that any external system comes and consume our API to get the response from our model. So now let me quickly change, and we experiment the two use cases that we discussed earlier. So we've seen that the knocks will be negative impact to our housing price. Also, whenever there is some nitric oxide concentration on the air, that will be reduce the price, housing price. Let me add one here and just to fire it. See here, right now we are getting just a 2.4, which means the price will be decreased a lot. Similarly, suppose if I increase the room, the price has to increase, because this will be the positive relation for the price. When I increase number of rooms, see now the predicted price is increased. So as we earlier seen that these two are negative and positive correlations, so that is what we are getting as part of the response as well. This is one of the use case that we have seen as part of this POC today. Also, I'm going to show the coefficients for these two attributes. Let me quickly go to the step 6. Coefficients, you see here, we have a Knox value that is -21. This will negatively impact our target variable, which is our price. Similarly, room, if you see, we have a positive, which means whenever there will be an increase in the room, our housing price also increased. The Knox value, whenever there is an increase in the Knox value, our housing price will be decreased. That's what we learned as part of this POC. Based on this model building, we have learned that Clean air influenced the value of the homes in Boston. Now let's look at the logs that we got as part of this API. I have mentioned the print statement in the log, the step 1 to step 5, so that we know what is coming into the model and what is the response from the model. Let me explain one by one. Based on the request that I fired, if you see here, this is what the values that we are getting from the API, and these values we are giving the input to the input payload to the model, and from the model this value we are getting the predicted value. So if you see the step 2 and step 2 especially we are getting the payload input, and step 3 we are feeding this into the model and we are getting the prediction out of it. As a summary, so far we have learned how to save a model as a pickle file and how to expose a model as an API to consume it from any of the external applications. Thank you so much for watching. Try to reproduce all these steps and let me know if you have any comments. The notebook and the source code available in the description below.